All right, so we're back here for part 3. And so now, the last two problems we're going to do are word problems, so 4 and 5. And we're going to talk about minimum and maximum and how we can interpret some data here. So example 4, a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. All right, just to get a little bit of a picture here, let's say that's our building, that's 40 feet up. We're going to toss a ball up, and eventually it's going to turn and it's going to come down. The ball's height above the ground can be modeled by the equation h of t, h is for height, negative 16t squared plus 80t plus 40, where t, h is the height in feet, h is the height in feet, and t is the time in seconds. Now that's important that we understand what the variables represent. So as time goes on, at first we go up, the ball goes up, but eventually it turns and it comes back down. So it should be this parabolic shape. And this is a quadratic function because it's a x squared or t squared. So, part A. What is the height of the ball after 1 second? Now 1 second is the time. The question is, what is the height? Well, let's take our value for t and substitute into our function here for height. So we're going to do h of 1. The t value is 1. So it's negative 16 times t squared plus 80 times t plus 40, and the t value in this case is 1. 1 squared is 1 times negative 16 is negative 16 plus 80 plus 40. And so when we add this up, what we're going to get is 104, and I'm going to write the word feet next to that. And the reason we know it's feet is we just found a height. So it's important, again, that we keep track of what is it that we're finding. If it's seconds, we need to write seconds. If it's feet or meters or whatever, we need to write that unit of measurement. So after 1 second, the ball is much higher. We started at a height of 40 feet. Now it's gone up to 104. Now just to show you, if I was to graph this with a Desmos or a calculator, first of all, on the calculator, when I hit graph, I don't see very much here when I do that. You can watch it happen. It almost looks like vertical lines. It goes up and off the screen, and then it looks like it comes straight down. But that's not telling the story. Remember, this has to be a quadratic, a parabola. So it's not straight lines, it's a curve. It's just so high that we can't see the curve. So if you're playing with a calculator, you need to change the window. You want to see the whole thing. So I'm going to change my y maximum. Let me try 150. Now you see it. Okay, so here's the curve. Oh yeah, that is a parabola. So after 1 second, we're pretty high here. Part B, when does the ball reach its maximum height? Now the maximum is the vertex, which is going to be here. Now I might be able to eyeball this and figure out, is it 2 seconds, is it 3 seconds? Not quite sure. I can try to do it that way, but honestly it's going to be a lot easier if I use the equation to find the axis of symmetry, the opposite of b over 2a. Now in this case, the b value is 80, positive 80, and the a value is negative 16. So we have the opposite of b divided by 2 times a. So we get negative 80 divided by negative 32. Now that actually does not divide perfectly. Negative 80 divided by negative 32 is 2.5. So we get a decimal. So it's a good thing, actually, that I didn't just guess 2 or 3 seconds, because it's going to be in the middle of that. Now, when does the ball reach its maximum height? Well, when x is 2.5. Now, in this case, we're actually talking about t, And what does t stand for? That is the time. So the time is 2.5 seconds. It takes 2.5 seconds for the ball to reach its maximum height, for the ball to get up here. So what is the maximum height? Now we're talking about y values. Now we're trying to find h. When, that's t, that's time, that's your x value. So what is the y value? If I look on my graph, how high does this go? That's what I want to find. Now, the way that I have it graphed is impossible to see. So let me do it algebraically. We know the x value. We know the time. So let's take the height function. And so that's negative 16 times t squared plus 80 times t plus 40. And the time, which we now know, is 2.5. Now I'm going to use the calculator to do this. So we're going to do negative 16 times 2.5 squared plus 80 times 2.5. Notice I'm using parentheses instead of a time symbol, plus 40. And we get 140. So 140 is the answer. Now what does that represent? That is the maximum height. So that is in terms of feet. In our picture here, the little picture I drew, that would be this point right here, that ordered pair, 2.5 comma 140. Now part D, what is the height of the ball after 6 seconds? Interpret your answer. So when t is 6, what's the height? Well, negative 16 t squared plus 80 t plus 40. And in this case, the height is 6, or sorry, the time is 6 seconds. So I'm going to go back in here and just change 2.5 to 6. So I'm just plugging that in and evaluating it. So 6 seconds, the height is negative 56. Now this is a height we're finding. Interpret your answer. Well, let's think about this here. How can you have a height of negative 56 feet? The ball goes up, hits the maximum at 140 feet, turns and comes back down. But unless we're going down into a valley or something, when you get to the height of 0, that's the ground, right? So the ball should stop there. So in this case, interpreting the answer, well, it means we are below ground level. And depending on the problem, and they don't say this, but basically that doesn't make sense. Unless, again, there's a big hole in the ground that the ball falls through. Okay, so that's the thing. This function is nice. It's nice to have this quadratic, but you also have to interpret it. The ball probably stops here, because when the y value is 0, that's when the ball has hit the ground, which means it's probably stopped, or it bounced, but it hasn't gone below ground. Okay, so that's something you need to think about in these application problems is, what's really happening, because sometimes there is a start and a stop. The other part to this, I'll come back to this, even though the graph keeps going to the left, if you go into the negatives on the x-axis, that means that time is negative. You've gone back in the past. And again, that doesn't make sense in this problem. All right, let's do one more here. Number 5. A rock is thrown upward from the top of a 112-foot high cliff overlooking the ocean at a speed of 96 feet per second. The rock's height above the ocean can be modeled by the equation. All right, here's our function. H is going to be the height again. T is going to be the time. When does the rock reach the maximum height? So if we want maximum height, what they're really talking about is the vertex. So let's use our vertex formula. X equals the opposite of B over 2A. The B value is 96. The A value is negative 16. So it's the opposite of B divided by 2 times a. And negative 96 divided by negative 32 actually works out to 3. That's kind of cool. Now 3, this is the time. This is 3 seconds. To find the height, so 3 seconds. To find the height, we need to put 3 into this function. So we need to do h of 3. So negative 16 times 3 squared. And again, this is something that I would be doing on the calculator. As a matter of fact, I am going to use the calculator. So negative 16 times 3 squared plus 96 times 3 plus 112 equals 256. So 256 is the maximum height. That's the height. The answer is not 3, that's the time. So 256 feet. All right, and now, well, actually, let's go back and read the question. When does the rock reach the maximum height? So actually, what they're asking, I misread it. When is the time that we want? So how long did it take? So the answer is 3 seconds. That's the answer. Now part B says, what is the maximum height? That's 256 feet. So that's okay, we just answered both questions. We just did it all in part A. But the when is the x value, that's the time. So we could have stopped here, and then for part B, that's where we have to plug in the time to figure out the actual height. Now the last question, when does the rock hit the water? In other words, when is the y value or the h value 0? When is the height 0? Now, this is something that we haven't learned this yet, how to solve it. That's going to be our next topic. All right, let me plug this in. I'm going to graph this and take a look. We're going to kind of eyeball this here. So let's go graph. Okay, we went up. Now, obviously, we're not seeing very high, but we turn, we come back down. Where do we hit? The water would be where the height is 0. So if I'm going to change my window again. Oh, wow, we're even going higher than that. Let's see if that's enough, 300. Okay, so here's the cliff. We start at 112 feet. We throw the ball up, it goes up, or the rock comes back down. Now it hits the x-axis here. That's the x-intercept. If I count 1, 2, 3, 4, 5, 6, it looks like 7. It looks like 7 seconds. Now again, I'm going to teach you how to solve this in the next lesson, but right now let's see if 7 is the answer. That's what we think. Okay, we think that the time is 7. Well, I can check that by taking the function and if I substitute 7, the question is, do we get 0? If we do, then that's the correct time. So we're going to work this out here. So it's negative 16. I need to change 3 seconds to 7. And do we get 0? Yes, we do. So the time is 7 seconds. And that is the end of the notes.